Today's stuff, Chapter 4, Section 5, is scatter plots. And trend lines. So scatter plots and trend lines. Going to start out with the scatter plots. Once we have that done, we'll talk about what a trend line is. So Roman number 1 is a scatter plot. And kind of the Falk version of the truth is a scatter plot is really just a graph of unconnected points. So a graph of unconnected points. If you're a hunter who hunts like ducks or something like that, you have the shotgun and you kind of shoot. There's all these little pellets for those people that aren't hunters. All these little pellets that are kind of spreading out. So it's not like you have one bullet to take down the duck. You have all these little tiny bullets. So your aim doesn't need to be quite as good. A scatter plot sometimes kind of looks like that. It's just a bunch of points on a graph. A lot of times it'll more be like in like a line or some type of a curve rather than just like this weird random connection. But what's the point of a scatter plot? Helps determine a pattern or a relationship. So helps determine a pattern or a relationship. Between variables. Here's my example. And this would fit nicely with a scatter plot because it won't be a straight line. But I do think that you're going to find some sort of a trend to it. So I'm going to make a graph. It's only going to be that first quadrant, the upper right. And I'm going to have the x-axis be, let's say, study time. And my y-axis, I'll say, is maybe the grades. So it could be for the quiz that we have coming up. It could be for whatever. But in general, if someone studies more, their grade is going to be higher. So we should have, kind of a pattern where people that don't study, the grade numbers are going to be a little lower. People that have more study time, the grades are going to be higher. But you get some people that are smart. So say you have somebody who doesn't study very much, and then say my two dots over here, focus, my two dots over here, this dot and this dot, do you agree they both studied about the same amount of time, about that much? But one person is going to do better than the other. Yeah, so they're smarter. Maybe they did the homework and they didn't cheat and copy down the answers. Maybe they came in and got some extra help. But so a scatter plot could be something like that. That you have dots there. Each dot represents an amount of time studying and a grade, in this case. They don't necessarily have to be all in a straight line or something like that. So the second thing we want to look at is correlation. So it's C-O-R-R-E-L-A-T-I-O-N. So correlation gets into, is there some sort of a pattern? Are the two variables connected? I'd build a case that the study time and the grades is. Typically, if people study more, they tend to do better. But that's not always true. You get some people that are just ridiculously off the charts smart and they don't study. She studies. Okay. Correlation. So a correlation describes a relationship between two data. It describes a relationship between is really pretty ugly. It's supposed to be between two data. So that last example we had, this here would be a positive correlation. That as one variable goes up, the other variable is going to go up. So I want to do 3 graphs. And so I'm going to make them pretty small. Actually, I probably won't be able to fit them side by side with my pen. But if we have something like this here, we'll do some examples soon of like real things. But this here would be a positive correlation. And by that, pretty much the way I look at it is though when my x values go up, so as I move across my graph that way, my x values are going up. When x goes up, y goes up as well. So an example of that could be something like the distance covered in your speed. Or you could do the grade and study time, so distance and speed. If you're doing how far can you bike in an hour? You know, if you have someone who's on a road bike, skinny tires, they're going really fast, and you have somebody else on a mountain bike with fat tires with the knobbies on them, the slower person is going to have a smaller distance. They're going to be one of the data points over here somewhere. The person that's going faster is going to have a higher distance. So they're going to have a larger x value, gives them a larger y value. Fair enough? Then our next example would be a negative correlation. So negative. What would you expect that graph to look like if it has a negative correlation? Perfect. Yep, start on the top and go down. It could be a straight line, but it could be kind of a scattering of points depending on what your variables are. Anyone want to come up? Well, maybe I'll write this. So when x goes up, y goes down. So when x goes up, as I move to the right on the graph, the y values, the height of those points drop. An example, if you want to pick one for our state, one of the real reasons they don't want to have the Asian carp coming into Lake Michigan is they think it'll kill off like the sport fishing industry, you know, that they eat up everything. So you could, if you wanted to, look at it as though the amount of money in Michigan fishing and the number of Asian carp. That's probably a bad example. Maybe do this. So say like grades and screen time. That's what we call it with our kids. You know, it's like the amount of time you spend watching TV and your grades. Typically, if people watch a ton of TV, their grades are probably going to be lower. I remember middle school, we talked about how much TV we watched that night, and one guy in my class, his name was John, he said he watched 8 hours a day. And I remember trying to think, how could you watch 8 hours of TV a day? Like physically, how much, like just being awake and at home, that's always kind of stuck with me. But I digress. You could, though, have some outliers. You could have maybe one person who, we'll put them like up there, maybe even higher. You could have somebody who, yes, they watch a lot of TV, but it's always the History Channel or something like that. Their screen time, they're spending time on YouTube, on Khan Academy, like watching all this stuff, all these different things, you know. Okay, last one. Last one's going to be no correlation. So no correlation. If you have something that's no correlation, the graph is going to look like... Random. Yeah, random. It's going to look kind of like nothing, you know, like you took a shotgun and just shot at the screen. So no correlation would be something like that. An example for no correlation might be, we'll say, grades and shoe size. Chances are your shoe size makes no difference on your grade. You could build an argument. Never mind. I was going to say, if you throw like a bunch of like fourth graders in here, then yeah. But maybe really advanced fourth graders. Okay. But your shoe size isn't related to your test scores at all. Good? All right. Which would it be? So what type of correlation would you expect? So the number of people living in a house and the size of a house. Positive. Because as the number of people go up, hopefully the size of the house goes up on average. Okay. Number of mosquito bites and the ounces of bug spray you put on. Negative.
Yeah.
Negative. Because if you put on more bug spray, the number of bites you get should go down. If you really lather yourself in it, it's supposed to just like a little, and if it's good stuff. But that'd be the whole scatter plot. It's not going to be a direct correlation. And some people, you know, bugs seem to like more. Okay. The number in college loans, the amount of money you owe in college loans, and the years in college. Positive. If you're in college longer, that's bigger. You're probably going to owe more money. The number of songs on your iPod and the size of your ears.
No correlation.
No correlation. Doesn't relate. We good on those then? Very last part. Last thing. Roman numeral 3 is going to be a trend line. And I started talking earlier before we did notes about your graphing calculator will do this for you. You actually can put points in your graphing calculator and have it give you a scatter plot. But in addition to that, if those points look kind of linear, like my positive and my negative there, your calculator can run kind of like a regression, they call it. It runs a little program in the background to give you the best possible line equation to go right through the middle of those points. where for now, we're just going to kind of estimate those. So a trend line, it's going to be a straight line through the middle of the data. So it's a straight line through the middle of the data. So a straight line through the middle of the data. And my other thing is going to be, it can be helpful for predicting y given x. So can be helpful in predicting y given x. So it can be helpful in predicting y given x. I'm going to just kind of make like a random scatter plot with what type of correlation? Positive. And I do something similar for yours. There's no point in trying to make your dots look exactly like mine. You just want to have some sort of a general trend. That's what we do, passing notes in class now or something. But okay, for that there, drawing your trend line, it's just kind of like you try to aim right through the middle. Okay, my trend line, too high, too low, perfect.
Perfect. No, too low.
Too low. So don't do this with real data, but for your notes' sake at least, there's more points that are above. The distance above those points is bigger than the distance below, right? So if you need to kind of try to save your trend line in an example in your notes, you can put in a couple more dots that are kind of down low. Don't do that on like a quiz or test. But for a quiz or test, I'll have rulers for you. Try to kind of get the ruler so it's going about through the middle of all the data, and then from there draw in a nice straight line. If it's reasonable, if it looks like you've put some effort into it, you'll probably get it all right. This last comment, this thing here, what I mean by that is if you're looking for, say you have like a scale on your x-axis, 0 to 10, and the question is saying, find y when x is 7. If we just had those dots, so 7, maybe right about there, should be my 7. If you just have the dots, it's a little bit harder. Do I go to that blue dot? Where do I go before I kind of hook left to find my y value? If you draw in a trend line first, you know that line's about the best approximation for your data. So then you go up to the trend line and then go straight across and say, okay, here's my y value when x is 7. So a trend line helps you estimate one value given another.